In this lesson, we are going to talk about theorems involving secants and tangents on circles. Recall muna tayo about secant line. When we say secant line, it is a line that intersects a circle at exactly 2 points. So, ibig sabihin, dalawang beses dadaan yung line na yon sa circle natin. Dito sa circle, yung line AB natin, twice siyang dumaan sa circle, it will be on point A at saka point B. Next, every secant contains a chord of a circle. So, based dito sa figure, yung line segment AB is a chord of that circle. Belong siya dun sa secant line natin na AB. Another line is what we call the tangent line. This line intersects a circle at exactly 1 point. So, ang pinagkaiba niya sa secant line twice siyang dadaan sa circle. Sa tangent line, isang beses lang. Exactly 1 point only. And yung point na yun, kung saan siya magta-touch sa circle natin is what we call the point of tangency or point of contact. So, dito sa figure na to, sa point T siya nag-touch sa circle. We also have secant and tangent segments. So, here we have tangent segment. Tangent segment is a point of a tangent line between the point of contact and a point outside the circle. So, dito sa figure na to, yung point T at saka point B, pag kinonnect natin, it will create a tangent segment. This tangent segment is a part of a tangent line that is tangent to the circle. Another is a secant segment. It is a part of a secant line that joins a point outside the circle to the further intersection point of the secant and the circle. So here in this figure, yung line segment AR natin is what we call the secant segment. Part lang siya ng ating secant line na AR. We also have what we call the external part of a secant segment. This is the part of a secant line that joins the outside point to the near intersection point. So here, on our circle, we have a secant line AR. And the nearest intersection from outside point is point B. So if we connect point B to point R, it will create another line segment, which is BR. This line segment BR will be the external part of a secant segment. Let's have this theorem. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So, dito sa figure na to, ang given daw natin, we have a line that is tangent to the circle. This line AB is tangent to circle R at point C. And then, ang conclusion natin, yung radius drawn to the point of tangency, that is radius CR, is perpendicular to line AB. That is our conclusion. They are perpendicular to each other. So, yun yung magiging conclusion natin. Kapag meron tayong given na tangent line, automatically, yung radius na drawing dun sa point of tangency at saka yung tangent line is perpendicular. When we say perpendicular, they will create a right angle kapag nag-intersect silang dalawa. In this theorem, ito naman yung kabaliktaran ng theorem kanina. So, sabi dito, if a line is perpendicular to the radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So, dito sa figure na to, we have here circle Q, tapos si line CD at saka si line QE ay perpendicular sa bawat isa. Since yung QE natin is radius of the circle, automatically we can say that DC is tangent to the circle Q. Or in other ways, so sabi dito, in circle Q, ito nga, circle Q, DC is perpendicular to QE. Ayan, dahil dito sa symbol na to. And since QE is a radius of circle Q, ang conclusion natin, DC, this line DC, is tangent to circle Q. Let's have another theorem. If two tangent segments are drawn to a circle from an external point, then those segments are congruent. This is what we call two-tangent theorem. So, dito sa figure na to, meron tayong dalawang tangent segments na na-drawing. So, we have tangent AB, tangent siya sa point B, at we have tangent AC, tangent siya sa point C. These two tangent intersect at external point. Ito yung kanilang intersection. Nasa labas to ng circle. Then, automatically, yung dalawang segment or dalawang tangent segment na to ay congruent. It means si AB and AC ay both tangent to this circle Q from common external point A. It means si AB at saka si AC ay congruent sa bawat isa. So, kung ang measurement ni AB ay 5, automatically si AC din ay 5. Now, let's discuss naman tangent circles. So, tangent circles are circles that intersect each other at exactly one point. So, kung kanina may tangent line, this time, tangent circles naman. Meron tayong dalawang circle na magi-intersect at exactly one point lang. So, dito sa figure na to, we have circle P and circle Q. Nag-intersect sila at one point. So, this one is what we call externally tangent. Externally tangent if each of the tangent circles lies outside the other. So, dahil sa labas lang sila nagdikit, it means they are externally tangent to each other. Yung isang case naman, here we have circle Q and circle P. This is what we call two circles that are internally tangent. They are internally tangent if one of the tangent circles lies inside the circle. So, kung mapapansin natin, itong circle Q nasa loob ni circle P. Pero, nag-intersect sila at exactly one point. Ayan, meron silang intersection dito sa point na to. So, since si circle Q ay nasa loob ni circle P, they are internally tangent. Next naman, we're going to talk about common tangents. So, common tangent line dun sa dalawang circle. Una, we have line PQ is a line of center. So, dito sa figure na to, this one is line PQ. Line of center kasi it contains the center of these two circles. Another, we have XY. This is the common external tangent. Ito yung XY natin. Itong XY na to is the common internal tangent of circle P and circle Q. Nasa pagitan kasi siya ng dalawang circle. Tapos, etong line na to ay both tangent to circle P and circle Q. Next naman, we have line AB is a common external tangent. Ito yung line AB. Parehas siyang tangent kay circle P at circle Q. Pero nasa labas siya parehas ni circle P and circle Q. Wala siya sa gitna. So, in other way, meron tayong definition dito when we say common tangent is a line tangent to two circles, not necessarily at the same point. So, tangent siya parehas dun sa dalawang circle. Yung line na yun ay tangent parehas dun sa dalawang circle, pero not necessarily exactly one point of tangency. So, dito nga, magkahiwalay yung kanilang point of tangency. Sa circle P, ang point of tangency ay sa point X. Sa circle Q, ang point of tangency ay sa point Y. So, magkaiba yung kanilang point of tangency. Another is the common internal tangent if it lies between the circle. So, sabi ko nga kanina, nasa gitna siya nung dalawang circle. Kaya siya tinawag na common internal tangent. Yung isa naman is common external tangent if it is not between the circles. Does not intersect the segment joining the centers. So, dito sa figure na to, yung line AB is the common external tangent. Nasa labas siya parehas nung ating circle P at saka circle Q. At isa pa, hindi niya may intersect itong line of center. Unlike si XY na intersect niya yung line of center. Now, let's have classification of angles with circles. So, meron tayong tatlong cases dito. Yung unang case natin, we have vertex is on the circle. So, dahil angles yung pinag-uusapan natin when we say vertex, yan yung intersection ng dalawang ray para makapag-create ng angle. So, dito sa unang figure, we have a secant and a tangent. So, pag nag-intersect sila, they will create an angle. Pero yung kanilang vertex o yung vertex ng angle ay on the circle. Same dito sa figure B. Meron tayong two secants nag-intersect on the circle. Another case is yung vertex is inside the circle. So dito meron tayong dalawang secant na nag-intersect inside the circle. So nasa loob yung kanilang vertex, yung vertex ng angle na na-form. Yung case 3 naman, yung vertex is outside the circle. So, dito sa figure A, meron tayong dalawang tangent na nag-intersect outside the circle. So, yung vertex ng angle na na-form ay nasa labas. Sa case B naman, o sa letter B, case 3, letter B, meron tayong 2 secant. Pero nag-intersect yung dalawang secant outside pa rin the circle. Yung vertex is outside the circle. And on the last figure, we have secant and tangent na nag-intersect din sa labas ng circle. Ito yung kanyang vertex at nakaka-create din ng angle. Now, dun sa next slide, i-discuss natin ano ba yung mga relationship ng mga angles na na-form dun sa intercepted arcs nila. Now, let's have the case number 1, vertex on the circle. So, dito sa figure na to, meron tayong circle at meron tayong isang secant line and tangent line intersect on the circle. Yung vertex ng angle na na-form is on the circle. So, sabi sa theorem, if a tangent and segment or a chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So, dito nga, ito yung ating tangent line. Nag-intersect yung secant AB dun sa point of tangency na B. Then, itong angle ABC is half the measure of its arc AB, yung intercepted arc na AB. Pag sinabing intercepted arc, yung arc na na-create dun sa loob ng angle. So, yung measurement nitong AB, pag hinati mo, yun yung magiging measurement ng angle ABC. So, dito nga, sabi, measure of angle ABC is equal to 1/2 the measure of arc AB. So, ito yung magiging measurement niya kapag ang vertex ng angle natin is on the circle. Now, let's apply the theorem on this figure, vertex on the circle. We need to find the measurement of angle BCD. So, dito sa figure na to, angle BCD is this one. Angle BCD, yung vertex niya is on the circle. At ang given niya is its intercepted arc, yung arc BC. Arc BC ang kanyang intercepted arc which measures 142. So, para ma-solve natin yung angle BCD, gagamitan natin siya ng formula kanina dun sa theorem natin, which is yung measurement ng angle must be 1/2 of its intercepted arc. Yung intercepted arc niya is yung arc BC. So, since yung arc BC is equal to 142, so, i-multiply lang natin siya sa 1/2 or i-divide natin siya sa 2. So, that is equal to 71 degrees. So, ang measurement ng angle natin, yung angle BCD, is 71 degrees. Yung next naman is yung arc ABC. So, yung arc ABC natin, etong part na to, yung arc ABC. And this one, that is the arc ABC. Now, since may given tayo na 90 degrees dito, it means this will be the angle na pwede natin pagbasihan ng measurement ng arc ABC. So, since given yung angle, pagbabalik ta rin natin, ang angle natin is 90 degrees. That is equal to 1/2 of the measurement of arc ABC. So, to solve for the arc ABC, ang gagawin natin, i-multiply both sides natin by 2 para matanggal natin yung ating denominator na 2 or yung 1/2. So, we can cancel this one. Ayan. And 2 times 90, that is equal to 180 degrees. So, yung measurement ng ating arc ABC is equal to 180 degrees. On case number 2 naman, yung vertex naman ng angle na na-form is inside the circle. So, sabi dito sa theorem, if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arc. So, dito meron tayong chord AD at saka chord BC nag-intersect sa point E. So, meron siyang na-create na angle. So, meron tayo ditong angle 1 at saka angle CED. Itong dalawang angle na to ay congruent dahil vertical angle sila. So, para makuha yung measurement ni angle 1, kunin daw natin yung half nung sum nung kanilang intercepted arc, which is the arc AB at saka arc CD. I-add lang yun and i-divide sa 2. So, ito yon. Measurement of arc or angle 1 rather, measurement of angle 1 is equal to 1/2 of yung sum ni arc AB at saka ni arc CD. I-add mo muna yung dalawang arc na yon and then divided by 2 para makuha yung angle na na-form inside the circle. Now, let's apply the theorem. So, we need to find the angle measure of angle SQR. SQR is this angle. Yan. Na-form siya nung merong dalawang secant na nag-intersect. Yung secant PR tsaka secant ST. So, para ma-solve yung SQR, i-add lang natin yung intercepted arc na PT at tsaka SR and then i-divide natin sa 2. So, sulat natin yung pinaka-formula. We have yung measurement ni angle SQR is equal to arc PT plus arc SR then divided by 2. Arc PT is equal to 32 degrees and yung arc SR natin is 100 degrees. Then, i-add lang yan and divided by 2. So, 32 plus 100, that is 132 degrees. Then, divided by 2, that is equal to 66 degrees. So, it means yung ating angle SQR is equal to 66 degrees. On case number 3 naman, yung vertex of the angle is located outside the circle. So, dito sa figure 1, meron tayong tangent and a secant. Ito yung tangent CD and secant AC. Intersect in the exterior of the circle. So, nasa labas nag-intersect yung secant at saka yung tangent. Then, yung measurement daw ng angle na na-form is half the difference of the measure of its intercepted arc. Difference naman. So, magsusubtract naman tayo dahil nasa labas naman yung angle na na-form. So, isusubtract lang natin yung intercepted arc. Yung arc na nasa loob pa rin ng angle. Yung bigger angle minus the smaller angle. So, ito yung arc AD minus arc BD and then divided by 2 para makuha yung measurement ng angle 1. Dito naman sa case na to, we have two tangents naman na involved. Nag-intersect outside the circle pa din. So, ganun pa rin. Kailangan natin isubtract yung mga intercepted arc na nasa loob pa rin ng angle. Pero yung case na to, makaka-create tayo ng isang buong bilog. Kadalasan, isang arc lang ang given. So, let's say given yung EHG. Yung EHG ay given. Para makuha yung measurement ng EG, isusubtract mo lang yung measurement ni EHG from 360. Kasi 360 yung measurement ng isang buong bilog. So, ang gagawin natin dito para makuha yung angle 2, EHG minus arc EG, then i-divide mo lang sa 2. Para makuha yung angle 2 natin. Next naman, dito sa third figure, we have two secant na nag-intersect outside the circle. So, sa labas pa rin. So, ibig sabihin, magsusubtract pa rin tayo ng intercepted arc. So, we have JN minus km and then divided by 2. So, ganun pa rin siya. Magsusubtract pa rin tayo and i-divide sa 2. So, kapag nasa labas yung angle na na-form, i-subtract lang yung dalawang intercepted arc and divided by 2. Now, let's solve for the value of x when the vertex is outside the circle. So, dito sa figure na to, yung angle na na-form is outside the circle. So, it means we need to subtract the intercepted arcs. Yung arc RS minus arc QS and then divided by 2 para ma-solve natin yung measurement ni angle RPS o yung angle P. So, to solve for that, i-subtract natin 174 minus 98 and then divided by 2. 174 minus 98, that is equal to 76, and divided by 2, that is equal to 38 degrees. So, it means yung measurement ng angle X natin, o yung angle P rather natin, is equal to 38 degrees. On the other side naman, sa kabilang banda, dito sa kabilang figure, we need to solve for angle F, yung measurement ni angle F natin. So, since ang given natin is yung EG, and wala tayong measurement ni EHG, to solve for arc EHG, that is equal to 360 minus 132, yung measurement ng ating EG. Kasi pag pinagdugtong mo yung EG at saka yung EHG, you will create a complete revolution or yung isang buong circle. That's why 360 minus 132 yung measurement ng arc EHG, which is equal to 228. So, since may measurement na tayo ng EHG, to get the measurement of angle F, that is equal to measurement ni arc EHG, yung mas malaki, minus, this is arc, pa-arc yan, minus yung measurement ni arc EG. Yan, then divided by 2. So, since yung measurement ni arc EHG ay 228, minus yung measurement ni arc EG na 132, subtract natin yan, then divide natin sa 2 yung magiging answer. So, 228 minus 132, that is equal to 96, and then divided by 2. So, 96 divided by 2, that is equal to 48 degrees. It means yung measurement ng angle X yung measurement ng X natin is 48 degrees. Let's have the summary of the three cases. We have on a circle, yung vertex is on the circle, inside the circle, saka outside the circle. So, para madaling tandaan, kapag on the circle, i-divide mo lang sa 2 yung intercepted arc para makuha yung angle. So, 120 divided by 2 is equal to 60 degrees. Dito rin sa pangalawang example, we have intercepted arc na 200. So, para makuha yung angle 2 divided by 2, kaya 100 yung measurement ng angle 2. On the second theorem, or yung case 2, inside the circle naman yung ating angle. So, ang maggagawin lang natin, i-add lang natin yung intercepted arc, and i-divide sa 2. So, 44 plus 86 divided by 2, that is equal to 65. So, yung measurement na angle 1 is 65 degrees. On the third case, yung angle naman natin is outside the circle. So, kapag outside the circle, half the difference of the measure of its intercepted arc. Isusubtract mo lang siya. So, dito, para ma-solve yung angle 1, we have 202 minus 78. That is equal to 124. So, i-divide mo lang yun sa 2. That's why we have 62 degrees. Dito naman sa second one, we have 125 minus 45 degrees. that is equal to 80 and divided by 2, that's why we have here 40. Yan yung measurement ng angle 2. Now naman, let's discuss power theorems. So, yung una nating power theorems is what we call 2-secant power theorem. Kasi meron tayong dalawang secant na involved. So, meron tayo ditong line 1 at saka line 2. They are both secant line. They intersect at the external point. Ito, nasa labas ng circle yung kanilang intersection at point Q. So, sabi dito sa theorem na to, if 2 secant segments are drawn to a circle from an external point, ito nga yung external point na yun, then the product of the length of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external segment. Ang haba, di ba? Pero, simple lang ibig sabihin. Yung product daw nung buong segment, itong buong segment na to, yung ating QS at saka yung external part niya, which is QR, pag minultiply, magiging equal dun din sa product nung kabilang segment or yung kabilang secant, yung buo times its external part. Or QR times QS, itong external part na QR times yung buo na QS is equal dun sa kabilang secant na QU, yung external part, at saka yung buong secant segment na QT. So, this is the 2-secant power theorem. Now, let's have the second power theorem, the tangent secant power theorem. So, dito involved naman yung isang tangent at saka secant segment or secant line. So, sabi dito, if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the length of the segment or of the secant segment and its external segment. So, meron tayo ditong tangent QT or tangent TQ at saka secant SQ. Sabi dito sa theorem, yung square nung tangent segment na QT, i-square mo siya, is equal to the product of the whole secant segment, yung SQ, times its external part na QR. Pag minultiply itong SQ times QR is equal to square nung QT. Pero take note yung tangent line tsaka secant line mag-i-intersect outside the circle para mai-apply natin ang tangent secant power theorem. Now, let's have the third power theorem, that is the two-chord power theorem. So, from the word two-chord, ibig sabihin, meron tayong dalawang chord na mag-i-intersect inside the circle naman. So, unlike dun sa kaninang dalawang power theorem, outside the circle nag-intersect. This time, inside the circle. So, sabi sa theorem, if 2 secant lines intersect inside the circle, the product of the lengths of segments form inside the circle are equal. So, ibig sabihin, since si SR, si chord SR, tsaka si chord UT ay nag-intersect inside the circle at point Q, ibig sabihin, yung product ni QR at saka ni QS, pag minultiply daw si QR and QS is equal to the product of QU and QT. Again, pag minultiply natin yung QR times QS equals dun sa product ni QT times QU. This is the two-chord power theorem. Now, let's try to solve these three problems. So, sa number 1, we have a tangent and a secant na involved. Sa number 2 naman, we have a secant or 2 secant na involved dito sa figure na to. And then sa number 3, we have 2 intersecting chords. Now, since segment yung involved dito, we're going to use the power theorem. So, let's solve for x dun sa number 1. So, remember, kapag meron tayong secant at saka tangent, yung square ng tangent is equal to the product of the whole secant segment times its external part. So, ibig sabihin, to solve for x, that is, ang formula natin, x plus 3, yan yung buong segment, times yung external na 3, that is equal to the square of the tangent, which is 6 squared. So, to simplify, 3 times x is 3x, then 3 times 3 is 9, next, 6 squared is 36, then, using addition property of equality, we have 3x is equal to 36 minus 9. And 36 minus 9, that is equal to 27. Then divide both sides by 3. So x will be equal to 9. So to check for that, kung 9 to, 9 plus 3, that is 12. So 12 times 3 is 36. Same with 6 squared, which is 36. Then naman sa number 2, yung whole secant times the external naman is equal to the whole secant times the external nung kabilang side. So, 9 plus 5, yan yung whole. 9 plus 5 times yung external, which is 5, must be equal to 3 plus x, yan yung whole, times yung x na external. So, simplify natin. 9 plus 5 is 14. Then, times 5. Sa right side naman, distribute natin yung x. 3 times x is 3x. Then, x times x is x squared. Then, 14 times 5, that is equal to 70. Equals 3x plus x squared. So, i-arrange natin, gawin natin siyang quadratic. We have now x squared plus 3x minus 70 is equal to 0. So, to solve for x, we need to do the factoring. Hanap tayo ng factors ng negative 70 na may sum na positive 3. So, ano kaya yung dalawang factors ng negative 70 na may sum na 3? So, it could be positive 10 and negative 7. Kasi pag minultiply natin, yung 10 and negative 7, that is negative 70. Kapag ka naman inad natin, 10 plus negative 7, that is positive 3. Then, equate natin both by 0. So, we have x plus 10 equals 0. It means we have x is equal to negative 10, which is not acceptable. Kasi nga, we are talking about the measurement. So, negative 10 is not applicable or it's not accepted. Yung other one naman, we have x minus 7 equals 0. So, x is equal to 7. So, since x is equal to 7 and that is positive, that is accepted. So, it means we have 7 plus 3, that is 10, times 7, which is 70. So, same din dun sa kanan na 14 times 5 is 70. Dito naman sa number 3 example, yung product daw nung part nung isang chord, yung dalawang part ng isang chord is equal to the product nung dalawang part nung kabilang chord. So, that will be 12 times x is equal to 8 times 18. So, multiply natin, we have 12x kasi 12 times x. Then, that is equal to 8 times 18. So, para mas maging simple, divide na natin agad by 12. Hindi na tayo mag-multiply. Pwede na tayo mag-proceed sa cancellation. So, dito, cancel na natin yung 12. So, x na lang yung matitira. And then, yung factor ng 8 tsaka 12, that will be 4. So, 8 divided by 4, magiging 2 na yan. And 12 divided 4, that will be 3. Next, yung 18 and 3 naman, pwedeng i-divide both by 3. So, 18 divided by 3, this will be 9 na. Sorry, not 9. It will be 6. Erase. 18 divided by 3, that will be 6. Sorry for that. And then, 3 divided by 3, that is equal to 1. So, since may natira tayo sa taas na 2 at saka 6, 2 times 6 is equal to 12. So, it means yung value ng x natin will be equal to 12.